Hello and welcome to my final project. I did Evil Hangman, so let's go ahead and jump right in. Here's the main game method. Start out by asking for a word length. Let's do that here. Here, enter an amount of guesses. It's done there. I ask if the player wants to do a running total of possible words, yes or no question. And that's done there. Once the user input's all in, then we could read the file, dictionary.txt. And it's done there. And then here I got the loop that's going to keep going until the game's over. So first we initialize the Hangman class over here, object. We're going to call it current game, and then it's going to do some things. Print the target pattern, the guesses left, guesses already guessed as an array list printed out. And if the player wants to do the running total, it'll do that right here in this statement. Then we're going to want some input from the user to store the guess as a single letter. And if they get it right, correct. Otherwise, nope. Once they run out of guesses or they win the game, it's going to check if the player won. It's going to print out the winner and give the final word that they guessed. Otherwise, you lost, and it's going to pick a word using this method that we'll talk later in the Hangman class about. And then we're going to ask if the player wants to play again, and that's done there. And if yes, then it's going to do all that stuff over again. Otherwise, I'll print out goodbye and game's over. So let's walk over to the Hangman class. We got the constructor here. It's going to take the word list, word length, and a number of guesses. It's going to initialize a bunch of variables, pattern, word length, and it's going to set the pattern to dashes using this for loop. It's going to make current options the word list because that's going to be changing. So you want to make that whatever the current options rather than all the options total, all 120-something thousand words. And then it's going to do letters guessed. It's going to create that array list to be blank at first. And then it's going to make the guesses however many guesses that the player wanted. Here we got some helper methods. That's just used for printing stuff or getting the values. Here's the first kind of method that does something else other than printer or something. It's called game over. And it's going to return true if you're out of guesses, if the pattern is a full word containing no dashes, or if there's no words left in your current options. Right after that, we got our player victory. And it's going to return yes or no if the player wins. If the game is not over, so using this method above, you can't win as long as the game is not over. So it's just going to be false. You didn't win. Otherwise, if the pattern doesn't contain dashes, it's going to do false, meaning that there still has unguessed letters in the pattern. So here's another helper method that should go up, actually. Out of place there. Now here we got the word choice. It's going to be dealing with word families of patterns. We're going to want to take a key. That's going to be our word family pattern, the word, and it's going to be used in the loop. So it's going to be a current word down later on, we'll see, and a hash map. So it's going to be the big hash map, kind of like a dictionary. I started out using hash map, so I just used that one instead of a dictionary. And it's going to use a string and an array list of strings called the word family map. And down here we got the meat and bones of it. We got if the hash map doesn't already contain our key, you're going to want to add the key along with an empty array list. Regardless if that's true or not, you're going to want to do this either way. This will add one word at a time to each word family's array list, and that's going to be inside a loop. So it only does it once here, but it'll be called on each word down in the main chunk of this class. Here we got a get winning word method. The game's over. This will be called to show the last word, and otherwise, as long as the game isn't over, the winning word will stay secret, so just be null. Here we got the get total unique characters method. And it's going to be passed in a loop. We're going to be looking at each word family's corresponding word. So it's going to be passed as the argument. And if it's empty, then just return 0 because you don't want any numbers in there because it's empty. And over here, it's going to iterate over all these words here in the list. We're going to make a char array for a current word, and it's just going to store each letter so we can easily dissect it for a loop here. And then we're going to use a hash set. The advantage to that is when you add something to it, there can't be duplicate items, so that's exactly what we want to do to get the number of uniques. So it works out nicely. Then we're going to iterate over each letter of this current word here. And as long as the char is not being guessed, it's going to want to add the unique characters to the result down here, and it's going to return that. So it's going to be used inside a loop. We'll see how that works here. Here's the next guess method. This is the biggest one. We're going to want to initialize all these variables. Use a hash map as a stand-in for the dictionary, like we said earlier. And it's going to just fill it with word families, keys, corresponding words that belong to each word family. So first we want to do check if the game's over. In that case, you want to just return if the player won or not. It has to be done first. Otherwise, we're going to do a bunch of stuff for no reason. Then next, we're going to want to iterate over each word in the array list current options. We're make a char array to easily create the current key with a variable for the length. Then we're going to want to loop until all the letters in word length are fulfilled. And then if the char at this index k is the same as the player guess, then we're going to want to set the current character of key to the player guess. So it's going to make the key nice and good. Otherwise, substitute the current character key to whatever the class variable pattern has. So previous guesses don't get erased or anything. They'll stay in the key. And then we're going to want to make a string out of that char array for the key. And then use that add word choice method earlier to add each word to a key. So the word families will get filled. And then down here, once the guess is processed, if that was the final guess, there's one left because we haven't called it guesses minus minus yet. So it's still going to be 1 even though it's the last one. Then we're going to want to check to see if our set of word families contains the class variable pattern. If so, we're going to want to update the current option to the words associated with the pattern, subtract a guess, make the winning word a word that reflects the current word family. And then we're going to want to add the guess to our letters guessed array list, and then return false because the player didn't win yet. Incorrect guess. Otherwise, as long as the guess is greater than 1, you're going to want to iterate over this key set for the word choices. Make that the current key. So it's going to go over each word family, the different patterns, and then if the reference pattern is not equivalent to any of the new families, you're going to want to do set our reference pattern to the current key for use in the next statement. Also, we got to do this if statement to compare the number of unique characters for both word families. And here we're going to do basically the same thing. After iterating through all the word families, the reference pattern should end as the word family with the greatest number of unique chars, making it the best option to use against the player. So that's where the strategy comes in here. Once the processing is all done, it's time to set the variables. So as long as our reference pattern is one of the word families, you're going to want to set all of this stuff. And that's pretty much the gist of it. So let's go ahead and run the game and see how it plays. We're hit word length. If you want to do like -1, it won't work. So let's just do an 8-letter word. Guesses. Let's do 8 guesses. No, let's do 10. And then let's show the running total. All right, so you can see how we have the word length of 8. So there's 8 dashes, there's 10 guesses, nothing's guessed yet, and the total 26,448 words to guess from. So let's just guess all the vowels first. A, E, I, O, U. So you can see there, I got a couple right. Now let's just guess some other stuff. Obviously I'm not going to win, so it works just like that. Alright, so there I lost. The final word was fluffing. I should have known. So basically there's no way to win unless you have more than 26 guesses, which all the letters in the alphabet. That's not a fun game to play. So that shows how the game works, and then if you want to play again, you can do yes or no. So I'll just show that it works. We got yes, we'll start a new game. Let's do something easy. Display the words. I'm just going to guess all the way across the keyboard to finish the game. And then see if you want to play again. I entered S because I was typing too fast. And then it wasn't a real answer, so let's just click no. And that's the game. Pretty good.